Plus, if I get my followings up to like, what, 20,000, I can start monetizing this. I'm at 28 now. So just a little bit further to go. And I'll be cashing out, man. It'll be awesome.
It's exponential growth.
All right, so let me, so yesterday, just to repeat that again, yesterday we're talking about how if I'm trying to go into parabolic form, which is that y minus k equals a x minus h squared, I need an a and I need a vertex. And a lot of times I'm given the vertex, so I can plug it right in. But sometimes I need to find that a value. Well, as long as I can isolate a or get a be the only variable left, I'll be okay. So if I knew another point, any point, I could plug that point in for x and y, solve for a, and I would have what I needed. Today we're going to be looking at function form, which is f of x equals ax squared plus bx plus c. And the f is a y, and the x are x's. They represent every point, including the vertex. There's no special h and k for the vertex anymore. The a is still the same, but you're going to have to use this information that I'm giving you to figure it out if it's in that, to get it into that form. The point is, you don't have to do what I'm telling you today all the time. And I'll explain that in a second. Just because I want you to end up in function form doesn't mean you have to work with function form. Because what you could do, sorry to make you stare, count this. What you could do to go from this form to this form is just multiply all this junk out, right? I mean, you could come in here and you could FOIL all of this, or use your expansion rules to multiply it out. Distribute your a into everything, right? Add k to the other side, and you would end up with a y equals something squared plus something x plus c. So remember, just because they say, I want you to end up here, doesn't mean you have to use the model that I'm going to show you today, which works exclusively with that. And with that in mind, on your test, which is in a couple of days, just because I want it in parabolic form, doesn't mean you have to work in this form all the time. You could use this and then just complete the square to get it to that. Are you with me? So remember, just because I want, it's like slope-intercept form. If I want something in slope-intercept form, I don't go through that antiquated mentality where I find the slope and I find the b value and then I have slope-intercept. I always plug it into point slope and then I convert it, okay? So my point is, whatever problem tells you to leave the answer in, don't feel like you have to use that form the whole time. You have both forms at your disposal. Okay, so here's what I want to talk about today. And I want to kind of show you something here. I have given you two equations, and I'm on page, 17 right here. Okay? And the question I'm asking you, these two equations, 0 equals that, 0 equals that, and I want you to solve. And another way of saying solve would be find the zeros, or find the solutions, or find the roots. Now, is that any different than saying find the x-intercepts?
Yes.
Why?
Because you can't have imaginary x-intercepts.
That's right. Y'all hear that? If I say solve, I can have imaginary solutions. Solutions and x-intercepts are the same. Solutions, zeros, roots, x-intercepts, they're the same if they're real. But if they're imaginary, they can still be all of these, but they would not be x-intercepts, okay? So, but this doesn't mention x-intercept. It says solve or find the zeros or find the roots of these two equations. Now, what I want you to see here is the only difference between that equation and that equation is what? The one on the right looks like I took this and multiplied 3 on both sides to get to here. So in the process of you solving, normally we factor if we can. This one actually does factor. This one I can't factor anything out, but I can break it up into 2 binomial factors, right? Whatever method you feel like you need to use for that. I can use the quadratic formula. If I did that, I'm going to get these 2 answers. The only difference is here, probably to make my life easy, I'd pull the 3 out first, and then I'm left with the same thing that I'd factor. Does that 3 give me a solution though? No. Now, I want to ask you this question. If these are the solutions or the roots, and they're real, these would have been the x-intercepts if this had been y equals, wouldn't it? Wouldn't it?
Yes.
And if these are the solutions or the roots and they're real, these would have been the x-intercepts if there was a y right here. So what's the major difference between these two parabolas?
One is one a lot wider.
Yeah, although because
wait,
they're
I
both
guess
bigger
it
than
wouldn't
one,
be
I would say that this one's a lot
Skinnier.
skinnier than this one, isn't it? Think about it. The A value is 6. Do you see it? Remember that A value on ABC is the same as the A value if it's in parabolic form? So that A value is 6, that A value is 2. So even though this one is a little skinnier than a normal parabola, that one is way skinnier. Are you with me? But they still both cross the x-axis in the same two spots. So I don't know what the vertex is on either of these. I don't know. I could figure it out, but I don't know right this second. But I do know that on this parabola, that one of them crosses at 4, that both of these cross at 4 and at what, -1.5?
Negative, yeah.
Right? So at -1.5 and 4, they both cross, but one of them is probably way, whoops, I missed it. One of them is way steeper than the other one. Now again, I don't know how low they go. That part I would have to figure out with some other information. Are y'all tracking with me so far? Because I'm going to come back to this. Well, what I'm going to be doing today is giving you the roots. And I'm going to be asking you to find the equation that these roots came from. And if you really think about what happened here, in this process, for me to find the roots, I had to factor it, set each factor equal to 0, and solve. Right? Both ways. So if I only give you these roots, logically, to go back to the equation, what would you do?
Same thing, just backwards.
Same thing but backwards. I would take these solutions. If I told you that -3/2 and 4 are solutions, well, then that means they're x values, which means I can subtract them from x, right? Subtract, now granted, if I subtract both of those from x, I'm going to get this, right? Are y'all with me? And then, if I don't like the fraction, I could use the fraction. But if I don't like the fraction, I could multiply both sides by 2 to turn it back into a nice, prettier looking factor. Are you with me? And then, once I have the factors, I can write them as a product of two factors, multiply them together, and there's my equation. But my question for you is, here, I ended up with this. Here, I ended up with that and had a random 3 in there from the beginning. I really don't know what kind of A value I'm going to have if it's a parabola, if all I do is give you two roots. Because the A values could be positive like this, but different values. They could be negative like this and have different values. Are you with me? So when you're doing this, if that's all the information you have, you technically don't know what that A value is. So if am I making any sense?
Mm-hmm.
If I give you these two roots and say, hey, give me a quadratic function, technically there could be a ton of quadratic functions. Because all you're going to know from these two roots is this part. You're not going to have any idea, and most people use the letter A right here, but you're not going to have any idea what that is. It could have been a 3 to give me a 6. It could have been a 1 to give me a 2. I don't know. That part of the function could be a myriad of different numbers. Are you with me? So the point of this is I want to say, if I give you roots, and I'm going to show you a little shortcut on this too. If I give you roots like this, all you have to do to come up with a quadratic equation that has these roots is subtract the root from the x, which is basically going to change the signs so that you turn them into factors. Take those two factors. I like to have whole numbers, so if it does have a fraction, I multiply through by 2 like we said. Take those two numbers, multiply them together. But remember that this is only one of an infinite number of quadratic equations that would still give me these two roots. Because couldn't I take this and multiply by 2 on both sides, multiply by half on both sides, multiply by -7 on both sides? It would still give me the same two factors, wouldn't it? Y'all with me? Now, on a problem like this that we're actually talking about functions, I would need to know more, right? This is fine right here. But if I'm talking about write the parabolic function, I'm gonna need to know that a value. So I would have to know something like, hey, what was the max? What was the min? Give me another point on the curve. Something like that to have more information. And if you had that information, then you could go in there and figure out what that exact a value is. And we'll talk about that in a second. Okay? So anyway, let me just go down here and give you another example. So bottom line, if you're reading through this with me, it's the same kind of situation. On a situation like this, I don't know whether this was my quadratic from those 2 points, whether or not I just randomly multiply by 3, it would still give me the same 2 roots. If I took this and multiplied by -5, it would still give me the same 2 roots. So when turning it into a function, it could have been any one of these 3 or any number of other ones, because I don't know that. Okay? So most people will end up writing this. They will write this, and they'll say, you know what? I really don't know exactly what quadratic function it is. I don't. So they would say, I would have to know something else. And they just use a different variable. Your book uses a. It's not going to be your final real a value, but they use the variable a, saying, hey, this would represent the family of quadratic functions. And then all you need to know is one other thing, like, what if I told you, hey, by the way, there's this extra point, 2, 7. It's on the parabola. What could you do with the 2, 7? Plug it in for x and y, solve for a, go back there and put the a in there and multiply it out, and then you would know the exact one that went with that particular situation. You kind of with me? And so the only real difference between this and what we did yesterday is I'm not using parabolic form. I'm using a different form. Okay? So come down to here. And I'm going to show you both of these ways. Here's the first one. So this, you may look at this and go, man, we did this yesterday. We did. And we did it with the the parabolic function yesterday. Today we're going to stick with just a quadratic equation. Okay? So right here, what if I asked you, find a quadratic function. Quadratic function is f of x equals ax squared plus bx plus c, which has those roots and a max of 10. I did this problem yesterday, didn't I? Didn't I? I mean, yesterday I said, graph these. And you went to -3, +5, and you knew the max was 10. So way up here at 10 was the max. And then what did you do? You said, well, if the max is 10, remember the max and the min is always what? The y-coordinate of the vertex? And then how would I find the x-coordinate of the vertex? Yeah, if it crosses through here and peaks there, the middle, the average of those two would be the x-coordinate, right? So you average those together and you get 1, and there's your vertex. So I could jump right to here. And then how would I find the a value?
You
Just plug in some point you haven't used, right? Now we've already used the vertex, so don't use it, but even if you did use it, you'd quickly see that was a bad idea, right? If I plug a 1 there and a 10 there, I get 0 equals 0a. Yay! That doesn't make any sense, right? So pick anything else like 5, 0, plug a 5 there, plug a 0 there, and I get 4 squared is 16, divide by that 16, so a is what, -5/8? And then you go back and you say, all right, y minus 10 is -5/8 x minus 1 squared. That's what I did yesterday. But notice all I did was use parabolic form, right? Today we're going to do it a different way. I don't really think it's easier, but it's a different way. But if the problem says write my answer as a function, not in parabolic form, I'm going to want it to end up looking like a function. If I did it this way, what am I now going to have to do to make it look like y equals or f of x equals? I'm going to have to multiply all that junk out. Well, to save that part of the step, I can do it another way. So that's what we're going to talk about today. So check it out. First thing I can do is say, well, if those are my roots, those are the x's when y is 0. That means that x is 5 and x is -3. And if x is 5 and x is -3, that means x minus 5 is 0. And that means x plus 3 is 0. And I can take those factors and write them down. All right? And if I FOIL those together, I get this. The problem is there a guarantee? There is one guarantee here. The guarantee is that this function goes through those two x values. But how do I make sure it goes up to 10? That's the part I don't know. Are you with me on that? So what I want to do here is say, well, I really don't know if it's that or if there's some other number out front. So I'm going to just put an a out there in my function, right? Instead of y equals this, I'm going to go y equals a times that. And now, how can I determine what the correct a is? Plug in some point that I haven't used. Now in this case, what's the point that I haven't used? The vertex this time. If I go and use 5, 0, look what happens. 25 minus 10 minus 15 is 0. Plug a 0 for y and I get 0 equals 0. Because I've already used the 2 points here. But the point I haven't used is the vertex. But I had to still find the vertex the same way I did yesterday, right? So I'm going to take the 1, plug it in there for x. I'm going to take the 10, plug it in there. And when I do that, you can see that right down here, I can solve for my a. So I get a is negative 5/8. And once I have that negative 5/8, I plug it in. And all I have to do now is to distribute it there. Not too bad, but it's another way of doing it. Now listen, I'm not going to make you do it a certain way. I'm going to make it optional for you guys. But I just want to I'd like to make sure that you know how to do both ways, because the better option, more options you have, the better off you're going to be. All right, and then you can see yesterday, I've already done this, but yesterday I would plug in the vertex and pick one of the points in there for x and y and solve for a. But the problem with that is, you can see, once I plug that back in, I'm in pretty good shape, but I'm going to have to FOIL that. I'm going to have to distribute a negative 5/8. I'm going to have to add that 10 to the other side and do all that math, but you're going to end up with the same equation for either one. Just a different way of going about doing it. But remember, it doesn't matter to me. Don't look at this and say, hey, you asked for a function. I have to do it the function way. I can still get f of x regardless of the way I do it. Just make sure you put it in the right form in the end. All right? Okay, now, I want to show you something. We call this the sum and product rule. You'll see it's not very creative coming up with this rule. It's probably the most obvious thing on the planet. But I want to show you something. And this little trick I'm going to show you is not going to save you much time when I give you simple roots like this. But it's going to save you a ton of time when I give you really ugly roots like 2 minus I root 3 or 2 plus I root 3. That's a little uglier, and I'll show you why in a second. But if I were to ask you, kind of like I did before, to find a quadratic equation with certain roots, I don't have to put it in function form because it says equation. So equation means it can be equal to 0. And if it's equal to 0, I don't have to worry about an a value. Okay? It doesn't matter what the a value is. If it's a function that moves through space, I got to know that a value because I got to know the curvature of that parabola, the direction of the parabola, all that stuff. So this just says, if I give you 2 roots, can you just find the equation? Now I want you to eyeball these. Take my word for it. These 2 roots gave me this. Now the process would be x minus 3, x minus 7, right? FOIL it all out. These 2 roots gave me this. The process would have been x plus 2, x minus 10, FOIL it all out. And then these 2 roots gave me this, but the process would have been, if I did it, x plus 5, x plus 8, to change them into factors, FOIL it all out. Can you see a little pattern going on here? What is this number right here coming from? It kind of looks like the sum, but the sum is 10. Sum is, so the opposite of the sum? So this number right here, the b value, is the opposite of the sum, or the negative sum. And what is this final value? It's just the product. So a shortcut to combining 2 roots into, to take 2 roots and create a quadratic expression that would represent the original equation those roots came from, is to do what we call the sum and the product rule. All right? And the rule is, you're going to just always put 1x squared down, okay? And you're going to sum the roots, but change the sign, and multiply that by an x. And then you're going to multiply the roots and just add whatever that product is. Sometimes you're adding a negative like you are here. Sometimes you're adding a positive like you are there. And you'll immediately go straight to an expression that represents those. And it saves you the trouble of actually changing them into factors. Now you may go, it's not a big deal to change that to an x plus 2 and that to an x minus 10 and to FOIL it out. I would agree with you here. But what if I give you these two roots? Now, if you think about it, these aren't factors because there's no x in them. Those are roots. They're just imaginary roots. And to change an imaginary root into a factor, you'd have to go x minus that, x minus that. Are you tracking with me so far? Then you'd have to distribute the negative out, and you'd end up with trinomials. Now, multiplying trinomials is not FOIL, okay? It's not just first, outside, inside, last. It's x times everything, which would give you that mess. Then it's negative 2 times everything, which gives you that mess. Then it's 3i times everything, which gives you that mess. So the foiling process of this is kind of nasty, right? Now, when you're finished with that foiling process, miraculously, everything cancels out and it leaves you something pretty great. But you can see I can cancel that negative 3x with that positive 3x. I can cancel that positive 6i with that negative 6i. And that negative 9i squared becomes a positive 9. So I'll eventually get it down to something pretty nice, right? But look what happens if you use the sum and product rule. If you have the two roots, rather than go through this mess, just go, what's the sum of 2 minus 3i and 2 plus 3i? What do I get if I just add them? 4. What do I get if I just multiply them? Well, you know they're conjugates, so what happens when you FOIL conjugates? What happens to the oi in the FOIL? It always cancels. So to multiply them, all I gotta do is FOIL them. First times first, last times last, clean up that, 13. Sum product. So all I gotta do, instead of doing all of this mess, is go x squared minus the sum times x. Remember, you gotta still change the sign, because right, it's opposite of the sum. And then plus the product. Bam. Now, if you like this, knock yourself out. But I'm a big fan of sum, product, plug it in my formula. A real big fan of that. And believe me, these aren't even ugly. Okay? I mean, I could have given you, 3/4 minus 5i root 2 over 6, plus or minus. Those could have been the two roots. Have fun plugging them in there, but it's going to be horrible, okay? But the sum and the product of these, I could do with minimal pain, still be semi-painful, but minimal pain, and then just plug them straight into my sum and product rule. Guess what people's biggest mistake is, other than just careless stuff, using the sum and product rule?
Not changing the sign.
Not changing the sign. It's by far the biggest mistake. Or making that positive and that negative, just getting the actual rule jumbled. Okay, or lastly, forgetting to tack the x onto the sum. They do stuff like x squared minus 4 plus 13 and end up with x squared plus 9. Remember, it's x squared minus the sum times x plus the product. But that's a nice little trick. Now, if I give you 4 roots, can you add all 4 of them up for the sum and multiply all 4 for the product? No, why not? Yeah, if I have 4 roots, it should be x to the 4th, shouldn't it? Not x squared. So if I had 4 roots, what you could do, though, is put 2 of them together and another 2 together and do the sum and product with each of those pairs. And then you're still going to be left with 2 trinomials. You'd have to FOIL the crap out of that, which is going to happen to you guys. So sometimes you do have to suck it up, but at least this helps the process a little bit. Okay? So, check it out. Use the sum and product rule. I'm asking you to. I probably wouldn't ask you to on the test. I'd probably say, all right, you got 2 roots there. Find the expression, the quadratic expression that would have these 2 values as roots. So a quadratic expression is like x squared plus something x plus something. Which 2 would? Now, you could make your life miserable and do this. X minus that. X minus that. You could distribute all that in there, FOIL it all out. Not me. I'm going to find the sum What's the sum give me?
6.
6. I'm going to find the product. What's the product give me? Be careful. 9. What's the outside inside do? Cancel. What's negative root 5 times positive root 5?
5.
Negative 5. And if there were i's, it'd be negative 5i squared, which would be positive 5. But in this case, it's not. So now that I have the two values, what do?
X squared.
Minus the sum
Plus, or X.
x plus the product. Done. And if I was asking you to find me the actual parabola, what do you know about the parabola? You could say, well, I know it's got to be y equals, and I know it's going to go through those two x values, but I really don't know about the curvature of it, do I? So what would I do to show the family of parabolas? I'd say, okay, I don't really know what that A is, so I'm just going to do that. That represents every single parabola that runs through these two x values. And by the way, if you're looking at these and going, how are those x values? What is root 5 ballpark me?
2-ish.
2-ish? So my two x values are actually 3 minus 2-ish, which is about a ish, and then a 3 plus a 2-ish, which is about a 5-ish. So this thing crosses somewhere like 0.2 whatever. Actually, that's like 2.2. So this thing crosses at like a 0.8 and a 5.2 or something like that. But I don't expect you to know exactly where that is. But if you had to sketch something like that, you'd go, well, that's, and does everybody know why root 5 is just a little bit more than 2? Because root 4 is 2, and root 9 is 3, and it's a lot closer to root 4 than it is root 9, so it's probably a lot closer to 2. So 3 minus 2-ish is probably somewhere right there. That's 1. And then 3 plus 2-ish, 2, 3, 4, 5, is probably a little bit past the 5. So but that's about all I would know. I don't need to be exact. I would just have to have an idea. All right, what about that ugly guy? It's imaginary, so that means this thing does not even have x-intercepts, right? But I could still find a quadratic expression if I did. Sum and product rule. Don't be intimidated. My goal is for you to be intimidated, but don't be. And by the way, does everybody see that writing it like that is just a way to write two of them real quickly? One of them is positive, one of them is negative. So there's the positive version. There's the negative version. So what do I get when I add them? Yeah, this cancels. 10 halves, which is 5. And what do I get when I multiply them? So 25 fourths. What happens with the outside inside? Cancels. And then the last would give me negative. Take your time on these. Negative what? 2 over 4, which is a half. I squared. And what does the I squared do?
Positive.
Makes that positive. And what's 25 fourths plus 1/2? That's 25 fourths plus 2 fourths. 27 fourths. So what is my expression?
X squared.
Minus 5x plus 27 fourths. Now, I'm going to throw out one more thing. What if I had said, find a quadratic equation with, this messes people up, but I'm not quite sure why, with integral coefficients that has these roots. Find a quadratic equation, so equation has to be equal to 0, or equal to something. Equal to 0 works. With integral coefficients. Now, what does an integral coefficient mean? This is not rocket science. Think about the words. A coefficient, that's an integer. Now, textbooks are really loose about coefficients. I define a coefficient as a number in front of a variable. But they describe coefficients as any number because their arguing is, well, this could technically be x to the 0. So they refer to coefficients and constants as coefficients. Very loosely, it's a little sloppy, but that's what they're saying. So all I gotta do to make sure that my integral, I have integral coefficients, is not have any what here? Not have any fractions, because fractions aren't integers. Remember, integers are just these. Positive, negative, whole numbers, 0, right? So what can I do right here to clean that up?
Multiply all by 4.
Multiply by 4, which is kind of like changing your a value, isn't it? So I still get the same roots, but I'm following the directions. If they say that, if I multiply by 4, nothing changes on the left. But it does look a little better, you know, maybe. Unless you love fractions, in which case I guess that looks better. You tried with me? Not too bad? Okay. So, real quickly, I'm going to do, I'll tell you, we kind of did number 7 already, where I showed you the 2 different options. Let's do this one, number 8. Make sure you're okay. And then I'm going to show you a couple of word problems, which most people would call the bane of their existence. When it comes to this chapter, really bothers some people, but I really like these. It really is putting a kind of real life. I know there's like real world in math, which really isn't the real world, but you're going to see this example right here. This could have actually been a real life model that this guy did and improved his production and his efficiency, actually helped out the economy because he's going to end up hiring more people, making more money, win-win for everybody, just because he knew how to do a little math. And people have bad businesses all the time because they don't understand mathematics. They think what they're doing is right. They might have a great product, but they don't know how to maximize their efficiency. Okay? They have this profit function and they're making profit. But making profit's a lot different than making maximum profit, right? So we'll take a look at that in a second. What time we got? 35?
15 minutes.
15 minutes? I think I'm good. Okay, so let's do option 1, what we did today, and option 2, what we did yesterday. It says determine the quadratic function when the min is -4, when x is 3. So I'm going to go ahead and sketch that. The min is -4 when the x value is 3. What did I just give you?
It's positive.
What did I just give you right there?
Formula.
I just gave you a vertex. You know that if we're talking about min or max on quadratics, we're talking about a vertex. And it says one of the zeros is 8. 4, 5, 6, 7, 8. So what do you know about this problem right here?
Going up.
It's going up. It has to be because the vertex is down low and it's a min. If you have a min, the graph is going up, right? Because there's no max. Do I have enough to actually do what we did today here? Today,
Yes.
I kind of do. It wasn't given to me directly, but indirectly I do. Because if I know that this distance right here is 5, and the axis of symmetry holds,
Yeah, you go the other way.
then I could go the other way 5 also, couldn't I? And now I have the 2 roots. And if I have the 2 roots, can I get a quadratic expression?
Yeah.
How? How do I get the quadratic expression?
It's just x plus 2, x minus 8.
Okay, so one option is to do x plus 2, x minus 8, and to FOIL them out. The other option is to do the sum and product rule, and the sum is 6, so x squared minus 6x. The product is -16 minus 16. And that jumps you directly to the quadratic part of the expression. But man, how do I make it go down to the vertex? I really don't know what. I don't know the a value. Something was multiplied by a value. Can I find that a value? I would just have to know something else, which would be what? Some other point. Which point is it you want to use? Why the vertex?
Because it won't give you 0.
It won't give me a 0. I haven't used it yet, right? So I haven't used it. Now, in the other situation, I use the vertex first. But in this case, I use the 2 points, the 2 intercepts, right? One that was given, one that I figured out. But now I can take the vertex, which I know is what? 3, -4. I can plug the 3 in for x, -4 in for y, and solve for a. If I plug a 3 in there, I get 9 minus 18 minus 16, which is what, -25? Correct me if you see an error. So what do I end up with? Y equals 4/25 And of course I want it in function form, so f of x equals 4/25 x squared minus 24/25 x minus 64/25. And I didn't say anything about integral coefficients or anything like that, I just said function. Function. Not too bad? Now, yesterday's method I kind of like better, to be totally honest with you. And yesterday's method, I don't even have to find the -2. Because yesterday what we learned is if you have a parabolic function, all I need is a vertex and an A. The vertex I know is at 3, the min was -4, that's the vertex. So y plus 4, a, x minus 3. How can I find a? Plug in a point I haven't used, 8, 0. I plug a 0 there and an 8 there. I get a as 4/25 when I divide. Notice, same a value. The only problem is, if I ask you for a quadratic function, what do I have to do now? And I said quadratic function. I'd probably word it better. I'd probably say in quadratic function form or in quadratic form, I'm going to have to multiply this out. So I'm going to have to FOIL that. X squared minus 6x plus 9. I'm going to have to multiply a 4/25 in, and then I'm going to have to subtract that 4 in the end. So in that function, and then change y to f of x. So 4/25 x squared minus 24/25 x plus 36/25 minus 4, which would be what? I have to find a common denominator. 100/25, and that leaves me with what? -64/25. You track with me? Okay, last thing. Biggest thing, and we're going to talk more about this tomorrow. I know tomorrow's our review day, but we'll have that whole period to talk more about these word problems if you struggle. So, real quickly, let's see if we can make sense of this and ignore all the writing right now. Okay? So, let's just say Biff was a piano maker, okay? And he's been making 35 new pianos a month in his company. Which is pretty great. Steinway's pretty expensive. And these are old numbers here, so we're just pretending. But let's just say that he's selling these pianos, he makes 30 per month, and his markup over his cost is 3,000. Do y'all know what that's saying? So
He sells it for
that's kind of his profit, right? So his costs are, I mean, listen, he's got to hire somebody, a woodworker. He's got to hire a musician to run the strings in the piano. He's got to buy the materials. There's a lot of expenses that go into making a Steinway, right? But once you have that done, he's got to make some profit, so he's charging 3,000 extra. And in his company, he's been selling 35 a month this way. Well, 35 times 3,000 is 105 grand a month. I would take that all day. As a teacher, I'd take that per year. But anyway, that's a lot of money he's making. Now, he could just sit down and go, I'm fine, I'm cashing out, life is good. But Biff went to my algebra class, and Biff decided, you know what? Profit, I want to maximize that profit. And we've been talking about maxes. Maxes represent what? The y-Pythagorean vertex. And I bet that there's a profit function, I'm screaming. I bet that there's a profit function that can be associated with this. And if it is parabolic, I can find the max there. Are you with me? Now, that whole curve, anything above the x-axis represents profit. But why would I want to make this much profit when I can make this much profit, right? And it might actually even help out the economy, right? Because if I have to make more pianos to make more money, I got to hire more workers. I got to buy more product. That can really stimulate the economy and help everybody, work out for everybody, right? Now, it might also mean, oh, if I make less pianos, I maximize my profit, you're fired. So it could go either way, but as a businessman, you have to make those, or person, whatever, you have to make those decisions. Now, this is what I know. Profit is that times that. Now, Biff did a little marketing research, or hired somebody, maybe paid him a little cash, figured this out, and he said, you know what? He figured out, based on some research, that every time he lowers the price just $200, he sells 5 extra pianos. I guess the $200 price swing brought some people over to his piano. They were buying it somewhere else. They're like, oh wait a minute, he's cheaper. So every time he dropped the price, he increased the number of pianos he could sell. How does that affect this equation? Every time I drop that by 200, and because I could drop it more than once or twice, I say 200x, I'm going to increase what?
The number of pianos.
The number of pianos by 5. So for each x I drop 200, I'm going to raise that by 5. That times that, when I FOIL it out and simplify, gives me a what?
Quadratic.
A quadratic. And what's my a value?
Negative.
Negative. And what does a negative a value do for me? Makes it go down. And when my parabola goes down, what do I have?
A max.
A max. So if I could figure out the max of this parabola, then that would tell me exactly what I need to do to maximize profit. Right? Because he's just going to randomly go, all right, I'm going to lower it. If he lowers it too much, he's going to make, if I lower that 15 times, I make nothing. Now, if his goal is to make no money, but to sell zillions of pianos to the world, great. He's got a great nonprofit going. Okay? But if he wants to make money, right, he's going to want to maximize his profit. So how do I find a vertex? If I have a parabola. Okay, I could complete the square, have fun, knock yourself. It's not impossible, but I could. But I kind of like using that little trick we learned yesterday, right? The vertex, the x-coordinate is always negative b over 2a. So if I took negative the b over twice the a, I get 4. What does 4 mean in this equation? Think about it. X is 4.
Multiplier.
Look at this equation.
4 equals x, so you just put it.
It means what? If x is 4, what did I just do?
And you just found the number of markup.
That was how many markdowns I did, right?
Markdowns.
So I lowered my price by 204. I lowered it by $800. How many extra pianos did I sell?
20.
Are y'all seeing that? So I sold 20 extra pianos, which is bound to mean I hired extra people, increased, right? I'm selling more pianos. I'm increasing music in the community. I'm having to buy more materials. Might be helping out the local wood guy or the ivory guy or the string guy or wherever I'm doing that. I'm hiring more people to put these things together. Win, 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 and I'm making more money, right? So if the question was, how much should I charge? How much should my markup be? What would you say? How much should my markup be? That's how much the original markup was 3,000, so 2,200 would be my markup, right? If I said, how many total pianos do I need to sell to maximize profit? 55? If I said, how many additional pianos would I need to sell? 20? If I said, how much should I lower my price? 800? All those are valid questions based on that X. Now, what if I said, what would my maximum profit be? And how would I get that? I take the X and plug it back in to find the profit. And if I plug 4 into my profit equation, right here I get 121 grand. Now guys, this is just Biff around the corner selling pianos. He just increased his price by $16,000 doing an 8-minute algebra problem. How many people, like, I love Onapoke. So good.
Oh, yeah.
And especially if you like spicy tuna or the salmon, it's so good. I would eat that every day if I could. I don't even care what it costs. But like if I'm a high school student, I'm like, dude, man, I go get the large Onapoke with fries. I'm at $16. It's a little pricey. Now, that might be the best they can do. But what if they got that price lower? Now, it might cut down on their per unit cost, right? But what if the guy at Onapoke found that if I lower the price, more people start coming in there, right? So even though his price, his margin, what he's making might be less, if his volume did increase, what's happening?
There are more customers.
I get more customers at a lower price, but my profit might go up. Now that might not be true. But what if he actually did some experimentation with prices and actually saw that? You start seeing a relationship there, and man, I'm increasing my price, but I'm also helping out vendors. I'm selling more product. Maybe I gotta hire more staff to come in there and work. Everything's a win-win. Now he also might figure out, man, if I raise my prices, people like me are still addicted, right? I'm still gonna go in there at least once a week. And that's kind of our routine. So I don't care what they charge me. I just love it. It's so good. If you want what I get to, I can give it to you. Who's been to Unapo? Wow. I really need to open one of those in Auburn. I think I would just slay it. I really do. There's so many people that run to Auburn, they're like, oh, they come back here and they're just hammering that Unapo. Anyway, whatever. But anyway, you're gonna see a problem like this. My encouragement to you to start out actually making sense of these, because sometimes there's a lot of information thrown at you. Start like this. What are they doing with no change? Are you with me? Start like saying, okay, 35 pianos, 3,000 a piece, that's what I'm making. Let that be your base quadratic function. And then say, how does each one change? And then make the change, and then just FOIL it out, and then you'll have your quadratic. So do the best you can on this, but my guess is you might struggle a little bit with those word problems. We have all day tomorrow to talk about it or anything else you want to talk about. And remember, our test is on Friday, all right? And let's start out this semester great.